Welcome. Recently, I gave a presentation to the university series, which is organized by the Catholic Parishes of Ventura County. The title of the presentation was Our Place in the Universe, and the theme that I wished to express in this presentation is the compatibility of science and faith, and the place that humanity finds itself in the cosmic scheme of things. Many of you were unable to attend that meeting in person, and so I've decided to record it again and post it on YouTube for anyone who wishes to view. I have to say that the presentation I gave was the first live presentation to an audience that I've given in 2 years, and my adrenaline was in full flow, and I was very excited about the experience, and I hope I can reproduce some of that in this recording today. Let's begin with the compatibility of science and faith. I would like to show a couple quotes from expert theologians. St. Augustine said that God was the author of both the book of nature, by which we mean science, and also the book of scripture, which represents faith. And since God is the author of both, they have to be telling the same story. Pope John Paul II said, if the truth of nature seems to contradict the truth of scripture, the problem must be in our own human understanding of one or both, referring back to the fact that both are that God is the author of both nature and scripture. My own view is that when practiced by people of good faith, both science and faith are sincere efforts to seek truth. And I like to make the analogy to binocular vision. We have two eyes that view the world from a slightly different perspective, and our eyes present our brain with two slightly different images of the world around us, two slightly different two-dimensional images of the world around us. And our brain intelligently combines these two slightly different images, focusing particularly on the differences between them, and it reconstructs a three-dimensional appreciation of the world around us. So this gives us depth perception, the fact that we have two slightly different views. And the analogy is that as individuals and as society, we can vastly improve our understanding of our existence if we can intelligently combine the perspectives of science and faith, which will always be slightly different. Neither one is wrong, just like neither image from your eyes is wrong, but each is somewhat incomplete. And the combination of the two is much richer than either by themselves. This is an image that was taken by the Cassini space probe as it orbited Saturn, and it went behind the planet into its shadow, and it pointed its camera back at the inner solar system and took this picture. And that pale blue dot at the point of the arrow is the Earth. And everything that humanity ever was, ever is now, and hopes and dreams to be in the future is confined to that pale, tiny blue dot. And it's easy to look at images like this and imagine that humans are so small, the Earth is so small, the cosmos is so big, how important could we really be? And indeed, the leading cosmologist of the day said referring to this and other images, that we are but a carbon smear on an insignificant rock, orbiting a humdrum star in an unremarkable galaxy in some forgotten corner of the universe. I mean, really, how depressing is that? And I'm here to tell you today why I believe every bit of what he said is wrong. Why I believe that every bit of our existence, every aspect of our existence is indeed remarkably special. And I group these special characteristics into four categories. The characteristics of our universe, the characteristics of the atoms of which life is comprised, the characteristics of our own planet Earth, and the characteristics of the recipe of our lives, which is encoded in our DNA, all of which are remarkably special. In the first category, scientists have discovered that the universe seems to be precisely tuned to enable life. And let me tell you what we mean by that. We begin with a statement from Albert Einstein, as does most of modern physics. And he said, what really interests me is whether God had any choice in the creation of the universe. And I think by that, what he meant was, do the laws of physics and math require a universe to be pretty much the way that we see ours to be? Or could the universe have been vastly different and still consistent with those known laws of physics and math? In Einstein's day, science didn't have an answer to this question, but now we know much more. And it turns out that our universe, in addition to the laws of physics and math, is characterized by 20 numbers. I call them knobs. Some scientists say there's 72 knobs. Some scientists say there's 36, but I'm going to focus on the most important, and that's a collection of 20. Now let's imagine, by analogy, that you had a machine that made cakes, and it had knobs across the front of the machine, one for the amount of flour, one for the amount of sugar, one for the cooking time, the temperature, and so on and so on. And you set the knobs to whatever you wanted. You pushed enter, and out came a cake that matched those knob settings. Now, if you finely tuned the knobs to just the right recipe, then you'd get a delightful cake. But on the other hand, if you just turned knobs to random values, you'd probably get something that no one would want to eat. Well, the universe is a bit like that. You could imagine a universe, a machine that builds universes, and you set the knobs to the kind of universe you want, you push enter, and out comes a universe which will obey all the laws of physics and math, but will be characterized by the settings of those knobs. Now, science has discovered that each of those knobs could have a very wide range of possible values, indicated by the orange range of the knobs shown here. And within that entire range of settings, every law of physics and math would be upheld. However, we've also discovered that only within a very small range of each of these 20 knobs would the universe be able to support any form of life whatsoever. Let me give you a couple examples. Protons and neutrons are the two components of the nuclei of every atom in the universe, and the ratio of their mass is very delicate knob. It has to be very precisely tuned. If the value of this mass ratio was 1/4% higher than it is, then there would be no atoms in the entire universe, no stars, no planets, no carbon, and no life. If the setting was 1/4% less, then stars would be extremely dim, and there would be no carbon and no life in the universe. So, for this particular knob, the probability of a random setting ending up in the green zone, the zone that would support any form of life, is 1 in 200. Those are not good odds, but it's certainly conceivable that we lucked out and got a universe with just the right knob setting. But many of these knobs are need to be much more finely tuned than that. So there's an asymmetry between matter and antimatter. We know what that asymmetry is numerically. In fact, that was the subject of my PhD thesis many, many years ago. I would rather not remember how long. And it's a very delicate adjustment. If there were just slightly less asymmetry in our universe, there would be no matter at all, and hence no life. If there was slightly more asymmetry between matter and antimatter, there would be so much matter that all of it would collapse into one giant black hole. And the odds that this knob is tuned to the green zone, the zone in which life is possible, the odds of that are only 1 in a billion. Now, that simply can't be an accident, can it? And the last knob of the universe that I want to discuss is the initial curvature. In Einstein's theory of general relativity, the curvature scalar c can have any value between -1 and +1. But it turns out that any value in the red zone here, significantly above 0, would result in a universe that would immediately collapse to a single black hole. And any value in the yellow zone, significantly less than 0, would result in a universe that expanded so rapidly that atoms would be millions of miles apart and certainly unable to collapse and form stars, planets, and life. So only if the curvature is extremely close to 0 can life be possible in our universe. And the odds of it being in the habitable range is 1 in this enormous number. And there are 50 digits in that number. And this is a staggering example of the fine tuning that's necessary for our life, our universe, to support life. Now let's talk about how special the atoms of life are. Here we see an actual photograph of the universe at nearly the beginning of time. This is called an image of the cosmic microwave background radiation, and it shows the universe when it was 36,000 times younger than it is today. So if you made the analogy between the universe and a 100-year-old man, this would be an image of that man's fetus 24 hours after the moment of conception. So you could say this is the ultimate sonogram of the universe. Now, let me emphasize that this is not a computer reconstruction, and this is not an artist's sketch. This is a legitimate photograph. So how can we get a photograph of something that's nearly 14 billion years ago? Well, that's because the universe is vast, and the opposite side of the universe is so far away that its light from the beginning of time has taken 14 billion years to reach our telescopes. So the image that we see today actually shows us an image of the universe as it was at this extremely early time in its existence. And from this and other data, we know that when the universe began, it was comprised almost entirely of hydrogen and helium, about 3/4 hydrogen and 1/4 helium by mass. And there wasn't a single atom of carbon or oxygen or iron in the entire universe. Well, hydrogen and helium are very nice, but they're both gases. They both make very small molecules, and there's no way that you could arrange a living organism comprised entirely of hydrogen and helium. So where did the atoms that enable life come from? And the answer is they were created in stars. Stars are the only place where the atoms of life can be produced. Stars form from these giant clouds of gas that collapse under their own self-gravity. Each of these pink dots that you see in the image is actually a brand new star. maybe even a brand new solar system. These stars collect in beautiful structures we call galaxies. This is the Andromeda Galaxy, our nearest neighbor, slightly more massive than our own Milky Way. This is the Sombrero Galaxy. It has 800 billion stars, and it has a black hole at its center with a mass of 1 billion times the mass of our sun. And in the center of all of those stars, in all of those galaxies in the universe, nature is cooking the tiniest atoms of light that existed and creating the heavier atoms that life requires. Carbon, nitrogen, oxygen, and so on, phosphorus, all the way up to iron. Well, it's wonderful that nature is creating these atoms, and it happens only because the knob settings are just precisely what they need to be. But life can't exist at the temperatures inside the center of a star, which could be 20 million degrees at the least, and up to 7 billion degrees in the most extreme cases. So the next essential step in the creation of the atoms of life is for them to be dispersed back into the cosmos. And that's what happens when stars come to the end of their lives. They explode and they cast off their inner contents out into the cosmos. And the most massive stars explode in catastrophic supernova that destroy everything for trillions of miles. But in that destructive process, they create the opportunity of life. They seed the cosmos. They seed these gas clouds with the essential ingredients of life, carbon, oxygen, nitrogen, etc. And those gas clouds later collapse and form new generations of stars, new planets, and ultimately lead to the emergence of life. This is an extremely delicate process. In fact, it's the most difficult thing that our universe has ever done. And just to give you some numbers to reinforce that, it took 30 billion trillion stars, that's a 30 followed by 21 zeros, burning furiously for 14 billion years, almost the entire age of the universe, to produce just 2%, to convert just 2% of the original atomic mass into carbon, oxygen, and the other elements that life requires. So all of these stars burning for this immense amount of time have just managed to convert 2% of the atoms into life. And if the knob settings weren't as good as they are, we would have almost none of these atoms in our universe. And these are the atoms that create us and create the Earth itself. So 90% of our body mass is comprised of the atoms that were produced in stars, mostly oxygen and carbon. Only 10% of our body mass is hydrogen, which was produced just after the Big Bang. And 99.99% of the mass of the Earth is comprised of atoms that were produced in stars. The hydrogen in all the oceans only amounts to 1/100th of 1% of the mass of the Earth. Okay, let's switch now to our place in the universe. And if you were to pick a random spot in the universe, it would almost certainly be completely empty, by which I mean it would be devoid of atoms. So, and this is the probability that it would be empty. And there are 39s there. So it is extremely probable that you would find empty space, because that's almost entirely what the universe is comprised of. So if you find anything at all, that's indeed rather unusual. And we find ourselves on a marvelous place. As far as we know, we exist in the only spot in which you can breathe the atmosphere and look through the atmosphere and see the majesty of the universe around us. And this is a very placid environment, as it turns out. The universe is much more dangerous and much more hazardous than we experience on Earth. Galaxies are continually colliding with one another, tearing each other apart, causing immense numbers of new stars and supernova that are destroying everything in their path. It's mayhem. This is a galaxy that was sideswiped by a larger galaxy and is now exploding. And if you think real estate prices took a hit in the last recession, just imagine what's happening in this galaxy. This is an image of a structure created by a black hole. This black hole has a mass 1 billion times the mass of our sun. It's located right at the center of this small dot. You can't see the black hole itself. It's completely black. What you're seeing there is the emission of light of matter that is falling into the black hole to its ultimate demise. And in its death throes, it's emitting this radiation that we see. We can also see streams of particles, which turn out to be moving at close to the speed of light, shooting out from the north and south magnetic poles that surround the black hole. And these streams of particles are blasting through the cosmos like giant flamethrowers, destroying everything in their path. This entire structure from end to end is the largest contiguous object that's been observed in the entire universe, and it is 5 times larger than our own galaxy. This object is not a good neighbor. Fortunately, it is about 3,500 million trillion miles away. By comparison, this is an image of the supermassive black hole at the center of our galaxy. We think all major galaxies have supermassive black holes at their center, and ours is a very low mass black hole among that group. It weighs only 4 million times the mass of our sun. It is thousands of times less massive than the black holes at the center of many other galaxies, which means it has consumed thousands of times less gas, stars, and the odd planet, and it has generated thousands of times less lethal radiation than black holes at the center of our galaxies. And this makes our galaxy much more benign than typical. This is a computer reconstruction of what our galaxy might look like if we were able to take a picture from extremely far away, which we cannot do. Our galaxy is of a type that's called a barred spiral galaxy. So it has this central bar, which slowly rotates, and coming off the end of this bar are arms that spiral outward toward the edge of the galaxy. And we are located in the suburbs, far from the mayhem of downtown, and far also from complete wilderness. Astrobiologists believe that the center of the galaxy contains too much radiation from the concentration of stars there for any form of life to persist for very long at all. And they also believe that the outskirts of the galaxy don't contain enough carbon to support life because they haven't had a sufficient number of very massive stars that have produced carbon. And so they estimate that only 10% of our galaxy, the Goldilocks zone, is far enough away from the center to be safe, but not so far that there is a dearth of carbon. And so it's the Goldilocks zone of our galaxy, only 10% where life is possible. And not surprisingly, the sun is smack dab in the middle. Next, let's talk about the special characteristics of the planet we inhabit. And in my books, I list, this slide first. This is a chart prepared by NASA and Caltech. And now that we have found over 4,000 planets that orbit stars other than the sun, these are called exoplanets. We can display all of these on this chart. And each one of these dots represents a planet not in our solar system. And I have added a dot to show you where Earth would be. And the key thing to get from this chart is that most planets in the universe that we have found are here, and Earth is not. So there are very few planets that are in the same region as Earth is in this chart, and the vast majority either are too big to support life or too hot, too close to their star to support life. So Earth is in a rather unusual position in this chart, almost unique. In my books, I list 14 characteristics of the Earth that are special. And I'm not claiming that any of these characteristics is absolutely essential for the existence of life, but I will say that every one of these characteristics makes a major contribution to making Earth a habitable planet. I won't talk about them all. You can read them in my books, but let me talk about a couple of them. First of all, our solar system contains only one star. That might be a funny thing to hear. After all, why should it be different? That's all we're used to. But in fact, most stars have partners, and most stellar systems contain 2 or 3 or more stars. And in a gravitational field with one central mass, almost any orbit around that star would be a stable orbit. So a planet could exist for a very long period of time in a stable orbit around one star. But if you have 2 or more major masses in a stellar system, then almost every orbit is unstable. And the planet would be engulfed by one of the 2 stars or ejected from the system in a relatively brief period of time, probably not long enough for life to evolve. Number 6 is the asteroid belt that we have in our solar system, and the fact that most of the asteroids that started in that belt have been displaced and ejected from the belt by the planets Saturn and Jupiter. And the reason that this is important is this is where the water that we have in our oceans came from. So in the beginning, Earth was a molten rock, and any water vapor that existed would have been boiled away. The hydrogen would have dissociated from the oxygen and floated off into space, and we would have had no water. And it's only after the Earth cooled and asteroids were displaced from the asteroid belt, fell into the inner solar system, some of which landed on Earth, bringing ice from the outer region of the solar system. And that ice melted and formed the water on the surface of the Earth. The last thing I'll talk about is Earth's magnetic field. We have an unusually large concentration of iron in our core, and because of the mass of the Earth and the concentration of various elements in the Earth, much of that iron is liquid, and that liquid iron in motion creates a magnetic field of great intensity. Earth has the highest magnetic field of any terrestrial planet we know, and that magnetic field protects our atmosphere from the solar wind. So Mars is believed to have had water on its surface and an atmosphere around the planet for an extended period of time after its formation. But because it didn't have a strong magnetic field and does not today, that atmosphere was eroded by the solar wind, this flow of particles from the sun that's continually emerging. And once the atmosphere was eroded, the oceans evaporated, and now Mars is a dry, dead planet. Now that we have over 4,000 exoplanets being discovered, we can start to make some statistical analysis of how special these characteristics of Earth are. At least we can come up with numbers for 7 of the 14 characteristics that I listed on the previous page. We will need more data to be able to evaluate the other characteristics. We cannot, for example, measure the magnetic fields of exoplanets, at least as yet. So these are the odds that any one of those exoplanets would match the Earth in terms of the special characteristics that Earth has. And as you can see, none of these numbers is terribly staggering, but there are many of them. And if you take the combination of all of these odds, you find out that the odds of an average planet in the universe matching these 7 characteristics of Earth is less than 1 in a billion. And there are 7 more characteristics for which we don't have data that are going to make this a much larger number yet. Now, the Chief Technology Officer of the Jet Propulsion Lab has said this in much more succinct terms than I have. He says, good planets are hard to find. He gave a lecture at Caltech, and that's what he had to say. I believe him because it's his job to find those planets. And he immediately followed that first statement by saying that we need to take good care of this one because we're not going anywhere else. Lastly, I'd like to talk about how special is the recipe of our life, our DNA. Now, the DNA of all life forms that have been examined so far are all constructed in exactly the same way. It's the double helix that you see on the right. And schematically, DNA is like a ladder. It consists of 2 rails, the deoxyribose sugar molecules, and the rungs of the ladder are the nucleotide base pairs. And life uses 4 nucleotide base pairs, which are labeled A, C, G, and T. And the combination of those letters is the recipe of life. And from a short segment like this, which is only 4 nucleotide base pairs long, you can't tell whether this is the DNA of an amoeba or an elephant. You need an immense amount of DNA to specify every necessity of life. In fact, each copy of the DNA in our bodies, in each of our cells, we have a copy of DNA, and each of those copies has 100 billion atoms and contains 3.2 billion nucleotide base pairs. And if you wrote out those base pairs, A, C, T, G, you would be able to fill 1,500 volumes of the Encyclopedia Britannica. Some of you who are younger members of the audience may not have ever seen the Encyclopedia Britannica, but it is a collection of very large books that spans at least 6 feet. Now, human DNA is by far the most complex and precise structure that science has ever discovered anywhere throughout the universe. And every human being's DNA is 99.9% the same as everyone else's. So it takes 99.9% of all of this DNA to define what a human being is. And it takes 0.1%, 1 part per thousand of the DNA to specify the difference between you and me and everyone else on the planet. It's the 0.1% that makes every individual a distinct person. I like to say that our DNA is 99.9% the same as Einstein's. So what excuse do we have for not doing what he did? Well, human beings are obviously a very complex organism, probably the most complex organism we know. And certainly we weren't the first form of life on the planet. I believe in Darwin's theory of evolution, and clearly that states that the first form of life had to be extremely simple, and more complex forms of life evolved thereafter from that initial simple organism. So how simple can the simplest form of life be? Well, this question has been studied, and the world's leading genomist, J. Craig Venter, published the results of his research, stating that the shortest DNA that allows an organism to perform all the necessary functions of life would have 462,000 nucleotide base pairs. Roughly speaking, 500,000 nucleotide base pairs is what it takes to provide for all of the proteins that are necessary to produce the atoms of the functions necessary to support life. How did that many nucleotide base pairs come to arrange themselves in just the right order to define that life? That's a fabulously intriguing question, in my view. And in one of my books that I'll describe later, I do a calculation of how likely it is that this could occur by random chance. Now, I start with the most generous assumptions. I assume that all of the carbon in the universe is consumed in making nucleotide base pairs. That's the most base pairs there could possibly be. That includes all the carbon in stars that's doing something else. But nonetheless, I'm providing the maximum possible number of carbon atoms. I'm assuming that every place in the universe is completely habitable, and almost none of them are. So that's an extremely generous assumption. I'm assuming all of these nucleotide base pairs can interact 1 billion times a second, which they can't because they're way too large molecules to be able to move that fast. And in any case, with all of these extremely generous assumptions, my calculation is that the odds of creating this many base pairs in the right sequence, even once, anywhere in the universe, throughout the entire age of the universe, the odds of matching that DNA even once is 1 in a number n. And you can't describe in simple English what n is. It's an immense number, and it has 203,520 digits. Now, to be clear, the odds are not 1 in 200,000. The odds are 1 in a number that has 200,000 digits. And if you filled a major book, a book like this with 300 plus pages, if you filled that book, you could fill the entire book with that number. You would start with 1 on the first page, and you would have 200,000 more digits to get to the last page. So those odds are absolutely incredible. It just can't be possible that this has occurred by any random chemical or physical process that science knows as yet. So, are we but a carbon smear on an insignificant rock, ... I say none of that, not a bit. We exist in a universe with knobs finely tuned to enable our life. We exist in one of the most benign galaxies that we know in the universe. We orbit a star which was born at the right time with the right ingredients, the atoms of life. We orbit an extraordinarily planet with all these characteristics that make life possible. We are made of the most precious ingredients that the universe has struggled for its entire existence to produce. And the recipe of our life, our DNA, is the most exquisite and complex structure that science has yet discovered. And so, as my grandchildren have always known, life is good. That's the end of the presentation. And there were many wonderful questions that were asked during the talk at the university series. And let me provide a discussion of some of those questions. I was asked what I thought about intelligent design. And if by intelligent design one means that the creator of the universe and the creator of life was an intelligent designer, then I have no argument with that view whatsoever. Science has no definitive evidence as to how and why the universe was created, or how and why life was created. And if one chooses to believe that it was created by a super intelligent being, then that's as good an explanation as any other. However, if by intelligent design, one means, as many do, that life was created 6,000 years ago with the creation of the universe, and that we coexisted with dinosaurs and so on, then I would say that that is strongly contradicted by firm scientific evidence. We know what the age of the universe is. It's nowhere near 6,000 years. We know that life has existed for billions of years on this planet. And the notion that all of this happened so recently simply is not correct. I was asked to compare the vision of God that is held by Jews and Christians, and by Christians. And while there is a great range of views that Christians have, and a great range of views that Jews have about God, there's one aspect of this that I like to address, and that is the issue of a personal God. So my favorite priest says that most Christians believe in a personal God. This is a God who cares for each individual, a God who listens to prayers of those individuals, and who may elect to intervene in the most, when you need him the most. Jews, on the other hand, believe that God is the creator, but that God does not control what happens on a day-to-day basis everywhere in the universe. God may be omniscient and benevolent, but he is not omnipotent. So he's a good God, but he cannot prevent evil. He created the world. He gave us great capabilities, and it is up to us to ensure that justice, mercy, and love prevail over evil on earth. I was asked, do scientists believe in God? And like most groups, some do and some don't. Newton and Einstein, who are the two most famous scientists and the most famous physicists in the history of mankind, each believed in God. They had different views, and in fact, they had unconventional views of God, but they did believe in a higher power. But it is not politically wise if you're a scientist to make that a common, to make your beliefs commonly understood. So if you were at a scientific convention And someone asked everyone who believes in God, would you please stand up? It's estimated that about 8% of the attendees would rise. On the other hand, if you call them in a private phone call, according to Pew Research, 51% of scientists would say that they do believe in a higher power. So while a slight majority of scientists are believers in a higher power, which could be defined in all sorts of ways, few would publicly admit it for fear of the reaction of their colleagues. And I'm afraid that this is a result of the battles that have occurred in academia over the teaching of evolution. The teaching of evolution has been vigorously opposed in many situations, and biological scientists who are teaching this have been attacked, and the reaction of other scientists has been antagonistic. Let's talk about what are the strengths of science and what are the strengths of faith? I was asked about that. So science is very good with numbers. If you have a question that can be answered by a number, science may be your best way to get that answer. So we know, for instance, the distance to the sun to about 2 parts per trillion. It's an extremely precise measurement from the distance from the center of the earth to the center of the sun. We know the age of the oldest rocks, the oldest meteorites that have fallen on Earth, and we know that to a precision of about 1 in 100,000. So we can tell you that the age of the solar system, meaning when did materials start collecting into solid objects like rocks, is 4,568,700,000 years, plus or minus 100,000 years. We know the age of the universe to a precision of about almost 1 in 1,000, 13.79 billion years. And science has a wealth of practical benefits in addition to these more academic pursuits. And economists have estimated that science is responsible for about 75% of the economic growth of our country over the last century. On the other hand, there are areas in which science is virtually useless. Science has no idea, and probably never will, be able to address issues like why the universe was created. In general, why is not a question that's well answered by science. Science can't address the purpose of human life. It just is. It has evolved through Darwinian evolution, but the only purpose of Darwinian evolution is procreation. Is there a purpose to human life beyond making more humans? One would hope so, but don't look to science for the answer. What are the principles by which a good person should live their lives? Again, there's no answer in science to that. You can't look at a physics equation and see the conclusion being that thou shalt not kill. Nature has no intrinsic morality. Nature has no intrinsic ethical principles. Nature is all about eat or be eaten, and make as many babies as you can. There are principles we should live by beyond that, and those principles have to come from faith. And in fact, I would say that all of Western civilization is based on principles that are espoused in the Bible. Even the most ardent atheists that I know several, still have a moral code, and whether they would admit it or not, that moral code ultimately comes from the Bible. And lastly, of course, science can't definitively answer the question of whether God exists or not. In fact, I believe science would never be able to prove that God does not exist. It's very difficult to prove that anything does not exist, but it would be more difficult even for God. And it can't prove that God does exist. Various scientists have claimed that they have shown that God either doesn't exist or isn't necessary. And I think all of those claims are fallacious. And the last thing I want to talk about is the question that came up is the comparison between the scientific theory of the Big Bang and the book of Genesis from the Bible. And they both describe creation, and how do they compare? In fact, I was invited by the Dean of Religion of Loma Linda University some years ago to come to Loma Linda and give a presentation. Loma Linda University is organized by the Seventh-day Adventists, and they describe themselves as the most conservative of Christian faiths. They're actually, many of their beliefs and practices are very similar to Jews. Their Sabbath starts Friday at sunset, as the Jewish Sabbath does, for example. In any case, they believe that or at least historically, Seventh-day Adventists have believed that every word in the Bible was literally true, and they believe in particular that the earth was created in 6 days. So the Dean of Religion, knowing that I didn't agree with that, invited me to come and present what science has to say about creation. So I put up this comparison, the theory of the Big Bang on the left and the book of Genesis on the right. And they both begin by saying that there was a beginning, that there was a moment in time before which nothing existed. And that's actually a very profound statement. That means that the universe has not existed for eternity. There was a definitive beginning. In the Genesis, God says, "Let there be light." And in the theory of the Big Bang, what came first was energy and space-time. And that's a physicist's definition of light. So we agree so far. Genesis says that God first created the heavenly firmament, and physicists believe that the universe first created stars and galaxies. Next came in Genesis the dry land, which is the planet Earth, and planets came after stars. Then life evolved, first plants and then the animals, and we agree on that. And lastly came humanity, and that's also consistent in both views. And now we come to the time scale, and Genesis says all of this took 6 days, and the Big Bang says this took 13.8 billion years. Well, the numbers are different. They're very, very different. But I would say, is the number the most important part of the message on either side? These are two different stories of creation. Anthropologists would call this a creation myth. And they come from thousands of years difference in time. They come from very different social organizations, and they are almost the same message. The similarity is extremely striking. I mean, in the time in which the book of Genesis was written, we didn't even know anything about the universe. And yet the description is very much the same. And as I told the Seventh-day Adventists, I don't think that the number is so important that you should change the name of your faith to the 8 billion year Adventists. That was sort of a odd joke to pull on them. And I wasn't sure if I was going to be crucified or they were going to laugh. but they thought that was one of the funniest things they ever heard. So they were a very generous and understanding group. And although I probably didn't change any of their opinions and they didn't change my opinion, we had a wonderful time discussing these issues, and they've invited me back 3 more times after that. So let me end with a little plug for some books. These are 3 books that relate to the subjects that we talked about in this talk. The book on the right, Science and Faith, Road to Harmony. I like the cover. This is a photoshopped version of the roof of the Sistine Chapel. God is reaching out to touch the hand of Albert Einstein rather than Adam. And this book most resembles the talk that I just presented. The book in the center is a physics book, and it's a gentle introduction with no math to all of modern science. So it talks about atomic physics, particle physics, relativity, quantum mechanics, astrophysics, and cosmology. And if you want to know what a neutron is and how it differs from a neutron star, then you can find that in the book. So it's an easy read. It's one of the highest rated physics books on Amazon.com. The book on the left is my analysis of the origin of first life. So it lists all the specific requirements of life, including a discussion of why carbon is the most essential element for the existence of life. And it quantifies the odds that each of these requirements could have occurred, been satisfied by random chance through any known physical or chemical process, ending with that analysis of DNA, where the odds are less than 1 in a number with 200,000 digits. So you can find all of these books and get them at the best price if you go to my website, which is listed at the bottom. So if you have questions, you didn't get to ask them at the live presentation, but you can email questions to me at the same through the same website, and I make a determined effort to respond to every question. So thank you very much for your time, and I hope to see you again.